All right, so let's hope that this works. Hopefully this lesson won't be too possessed by the ghost of the menu. We'll call it the ghost of the menu. So in this chapter 5.6, we're going to be looking at the properties of linear relations. So do you guys remember what the word linear means? Straight line. Yeah, so it means that it is straight line. Now why won't this go away? All right, so now we need to determine whether these table of values is representing a linear relation. So that means, is the relationship between the x's and y values look like a straight line on a graph? Okay. Do you remember the term rate of change from grade 9? Rate of change, yeah? Okay. So we're looking at the change. So that's what we're going to do. We're going to look at the change in time. So what is the change in time here to here to here to here and to here? Is it exactly the same for all of them? It's all 20, right? This from here to here is 20. This is 20. From here to here, it's 20. From 60 to 80, it's 20. All right. Now, what can you tell me is the rate of change between 1 and 2? What is the rate of change between 2 and 4? What is the rate of change? What is the change between 4 and 8? 4. What's the change between 8 and 16? 8. What is the change between 16 and 32? 16. Okay, so what can you tell me? These are all the same, right? These are all constant over here. And what can you tell me about these here? Those are not constant. Not constant. And yeah, they do double. But they don't go up by the exact same number each time. Like you can't add the same number each time. Yeah, they double, which means that it's something other than linear. It's not a straight line. So since both n and t do not go up by a constant, not both of them, only one of them does. The t does, the n does not. The n does not go up by a constant number. Okay, I'm not adding the exact same thing each time. Then I declare this one. See, there's that ghost. I declare that this is not linear. It is not linear. Okay, let's have a look at the next one. The next one, in B, it says the relation between the amount of goods and services tax charged, so that's the GST tax, in T dollars, and the amount that was purchased in A dollars. So this is what's being purchased, and this is your tax that you're being paid. All right, so is it a constant rate? You need to see what's the change in all of your A values. What are the changes from here to here? So it's 60 here, and from 120 to 180 it's another add 60, and then from 180 to 240 you are adding another 60, and then from 240 to 300 you are adding another 60. So each time we're adding 60. Okay. Now, let's look at from 3 to 6. What do I add to get from 3 to 6? I add 3. What do I add to get from 6 to 9? What do I add to get from 9 to 12? I add another 3. And how about from 12 to 15? 3. Okay, so what can you tell me about the changes in A and the changes in T? They each go up by a constant number, right? So since the change in both variables is the same or is constant, it is a linear relation. Yeah. So since the changes in both variables I should say are constant because it's plural. The table of value represents a linear relation. So constant, both variables are constant. It's linear. All right. So now the next question looks at graphs of equations. And what we're going to do is we're going to set up little tables of values so that we can graph them and see the graph. So now let's try graphing these. So which represents a linear function? All right. Table of values. So let's set it up here. My equation is x equals -2. And I've got x here. And then y there. All right. So what are my only numbers for x that I'm allowed to choose? -2. It says x is always equal to -2. I could have a value of -1 for y. What if I had a value of y equals 0? What's my x value going to be? -2. What if I chose a y value of 10? What is my x value going to be? -2. Do you see a pattern here? No matter what I choose, well, no matter what my y value is, what is my x always? It's always -2. So that occurs right here. So when y is 0, x is equal to -2. So x is equal to, when y is -1, x is equal to -2. When y is 10, up here, y is -2. So no matter what I end up with, no matter what y value I have, oh boy, I'm trying to make a straight line. I'm trying to make a straight line that goes vertical. And it hits every point where x is equal to -2, no matter what my y value is. Is this linear? Is it a straight line? Yes, it's a straight line. Yes, this is linear. The graph is a straight line. Okay? All right. Now let's try the next one. The next one says y equals x plus 25. All right. So when y is equal to x plus 25, well, let's set up a table of values so that we could plot some points. So I'm going to choose x values, and I'm going to figure out what the y value is going to be. So this is my y equals, right, over here. All right, so let's pick a couple of values of x. Let's say I pick x equals negative 20. What is x equals negative 20? When I substitute it in there, I get 5. How about when x is equal to negative 10? What is y? 15. How about when x is equal to negative 5? I get 20. How about when x is equal to 0? 25. Y is 25. How about when x is 5? I get 30. And when x is 10? 35. And when x is 20, I get, all right. So let's plot these points on my graph, remembering that x is on the horizontal and y is on the vertical. What do I end up with? Okay, so negative 25 is somewhere here. Watch your scale so that you can see. So these are going up by 2's, right? Okay, so negative 25 is around here, and then I go, wait, that's my x-axis right up here. And then I go 5 up, so I'm going to try to hit it. Okay, so now negative 10, and I get y equals 15. So negative 10 is here, and then up 15 is right around here. It's hard to see my scale. And then negative 5 is here. Negative 5 is here, and then I go up to 20. So that's right here. So that's somewhere right around here. Okay. And then 0 and 25. So that I think is right there. And what happens with my other numbers? If I have x equals 10, it's off my graph, right? But it's going to be somewhere up here. Okay, so hopefully you've got a ruler and you can do a better job of graphing than I can on this grid and this pen. It's hard to see the numbers, but what's going to happen is your line, they're going to go through, whoa, oh boy. There's the ghost of the menu. Okay, is going to end up looking like this. All right, so is that a straight line? Yes, well, yeah. On a piece of paper with a ruler, is it a straight line? Yeah. Okay? All the dots kind of fit perfectly. So is this linear? Yes. Yes. Linear. Why? Your reason is because the graph is, all the dots are in a straight line. Okay. Next question. So now we're going to graph, now we're going to graph y equals 25. Okay, so y equals 25. Any guesses of what this is going to look like? Yeah, it's going to be a horizontal line. If I make a table of values, any value of x that I choose, what is your y always going to come out as? It's always going to come out as 25. So no matter if I choose negative 10, 0, or positive 10, or any other number, my y value is always going to be 25. So it's going to be straight across. All I need to do is try to find 25 on this scale properly. So 20, 2, 4, so it's right there. So draw a straight line across, all the way on the graph, have arrowheads on the end, indicating that it is continuing on either side. Pretty easy one? Yeah. All right, and then our last one. Any x location you choose, your y value is always going to be 25. Yeah. Because your equation is y equals 25. There's no x value in the equation that's going to change it. All right. Okay. So let's try the last graph here. So the last graph says x squared plus 25. So let's draw a table of values and see what's going to end up looking like. So my table of values, let's set it up so that it is x and then y equals x squared plus 25. So I'm going to choose some values of x and see what we come out with. So notice my scale has changed on this graph, right? And it's changed for a reason. So let's choose minus 10, negative 5, 0, 5, and 10 as my x values. So what are my corresponding y values? What is the y value for the first one? 125. What's my next x value? 5, 0. What is my y value for 0? 25. And how about for 5? 50 and 125. All right. So if I graph this, any ideas of what this is going to look like if you graph it? It's going to be, why do you think it's going to look like a U shape? Yeah, so you get the same y value for two different x's, right? So when x is negative 10, I get 125, which is somewhere here. And when x is positive 10, I get y is 125. Oh, here, I'm going to move this guy. Has an affection towards me for some reason. Okay, I'm not doing anything. I don't know what's happening. Okay. Yeah, I think there's a ghost. There's a ghost in the computer. So now when x is -5, I get what values for, I get 50? So that's right here. -5, 50, and then +5 it is 50 as well. And how about for 0? When x is 0, 25, so that's right there. So notice I've got dots on this side. Uh-oh. All right, I've got dots here. And it curves and then goes up. I totally missed that one. Like that. All right, there. So that's what my graph kind of looks like. It looks like a U shape. Is this linear? No, not linear. Why is it not linear? Because it is not a straight line. All right, the graph is not in a straight line. Okay, not too bad, hey? Little table of values, graph it quickly to see. Now, did you notice anything between the equations of all of the questions that we've just done? Which one turned out to be not linear, and how did the equation look different? So it had an x squared, right? Everything else, did it have a square anywhere? No. Now, all of a sudden, this last question had a square in it, and it turned out to be nonlinear. So that's also something that we're going to recognize. Okay? All right, good. So let's try the next one now. The next one talks about a couple of situations, and you have to figure out whether or not it is linear based on the situation. A dog sled moves at an average speed of 10 kilometers an hour along a frozen river. So we're looking at the relation between the distance that's traveled related to the time. So if we're given speed, how can we figure out the distance that's traveled when we're looking at time? DVT, okay, sure. What does that mean? Okay, so the distance traveled is the speed times the time. Okay? So if I set up a little table of values and I say x, so what is x? X is my time. And if I set up this so that I've got my y, what is my y representing? Distance. Okay, so this is time. All right, so at time 0, how far have we traveled? We've traveled 0. At time equals 1, so after 1 hour, how far have we traveled? 10 kilometers. After 2 hours, how long have we traveled? After 3 hours, how far have we traveled? 30. Okay, so what can you tell me about the relationship here? Time goes on. Time is going up by 1 hour each time, right? And how much is our distance changing each time? By 10. Okay, so then is it a constant? Are you sure? Yeah. So here we're going +1 each time, and here we're going +10 each time. Constant rate of change means So both variables are going up exactly by the same amount each time. This is linear, okay? All right, now let's have a look at the area of a square. So the area of a square is related to the side length of the square. So you all know what a square is, right? So I've got my square. The side length is x. The area is y. X squared, yeah. So the area is x squared. Perfect. Let's have a little table of values here. So the length is x, and then what is my area? Y. Let's say I have a square of length 1. What's my area? Let's say it's now a two-sided. So it's 4. And then how about if it has a length of 3? 9. Do I need to continue? No, why not? This is going up by 1, but this is going up by 3, and then it's going up by 5. So I can see right here that it's not a constant at all. So since the area is not increasing by a constant rate, this is not a linear. Not linear. Area does not go up by a constant value. Okay. Okay, so now let's look at the next question, which refers to a hot tub that contains 1,600 liters of water. Graph A represents the hot tub being filled at a constant rate, and graph B represents the hot tub being emptied at a constant rate. What do you notice about the two graphs that you see here? Okay, so we notice a couple of things. That graph A is not as steep as graph B. Okay, now graph A is sloping upwards. It's going uphill, right? You see how this line is going up like that? That means it is increasing, right? The volume is increasing as time goes on. And how about this one? Graph B, you're emptying it. It's decreasing over time because your slope is downhill. Okay, so we should have a positive rate of change for this one and a negative rate of change for this one. All right. Which one's faster? B is faster. Why? It's steeper. Okay. All right. Good. Good observations. So what is the dependent variable here? Volume. Okay. So volume is the dependent variable. And what's the independent variable? Time. So volume. You know what? I'm going to scroll it up, and then I'm going to write it in. Okay. So dependent variable is volume, and it depends on the time, so that's the independent. Now, how do we determine the rate of change? So what is the change of volume when we're going from here to here. So from here to here, what's the change in volume? So it's positive 800, right? All right. Now what is the change in time? 40 minutes? Okay. So my units here, this is liters and this is minutes. So what is the rate of change for graph A? Plus 20 liters per minutes. All right, now let's do the same thing for graph B. How is it changing from here to here? So it's going down 800 liters. And how long does it take to do that? Why is it only 20? What are you noticing right there on the graph? That this starts at, right here, that's 20. So what's the difference here? That's 20. So that's why over here we have 20 minutes. Good observation. So what's my rate of change for this one? Minus 40 liters per minute. Does that make sense that this one is positive here? That graph A is positive and graph B is negative? Yeah, why? In real life, why? The second one is losing water. It's getting emptied. It's getting smaller. Right, good. Okay, perfect. So remember the questions at the bottom there, the homework? Make sure you guys are doing the homework, right? And asking me questions. All right, sweet.